In this video, we're going to be solving a simple equation with subscripts, and we're going to be talking about the fact that subscripts don't really change what we know about simple equations. So in this particular equation, we have r sub a, so this is one letter r, and then the subscript is a, and we read this as r sub a. So r sub a times t sub a. Well, you have to think about r sub a as just a single variable like x, and t sub a as a separate variable like y. So when we have some value here and then a subscript, the two together are just a single variable, represent a single value. So really we just have r sub a times t sub a plus r sub p times t sub p is equal to 200. And the reason that we sometimes use subscripts instead of just variables is that they can be very descriptive, much more so than variables. So for example, if we have this problem here where a represents Andrew, and P represents Peter, and we want to say Andrew's rate times Andrew's time plus Peter's rate times Peter's time is equal to 200, then using these subscripts can be very descriptive, as opposed to if we wrote this equation as x times y, where x is r sub a and y is t sub a, plus r sub p is, let's call it w, and t sub p is z, we'll say x times y plus w times z is equal to 200. When we're talking about Andrew's rate and time and Peter's rate and time, writing it this way is much more descriptive than writing it this way, because x, y, w, and z have no correlation to Andrew or Peter or rates or times. But when we use variables here with subscripts, we can write an equation that's very descriptive and we know exactly what we're dealing with. So we've been asked to find Andrew's rate. We know right away that we're trying to find r sub a, because r sub a is the rate of Andrew. So that's the variable that we're trying to solve for. We've been given some other values here. So we know that Andrew's time is 3 hours. We know that Peter's rate is 20 miles per hour, and we know that Peter's time is 4 hours. So if we just plug these values in for the variables with the subscripts, then we can go ahead and solve for Andrew's rate. So again, knowing that Andrew's time is 3 hours, we need to plug 3 in for t sub a. We know t sub a is equal to 3, so we're going to get r sub a, and then we're going to multiply that by 3. Then we're going to add to that, because we have addition up here, r sub p. Well, we know that that's Peter's rate, and we've been told that Peter's rate is equal to 20, so we'll go ahead and plug in 20. And then we have to multiply that by Peter's time. We've been told that t sub p, Peter's time, is 4 hours, so we'll go ahead and plug in 4 for t sub p, and that's all equal to 200. And now we just go ahead and solve. So we say r sub a times 3, we can call it 3 r sub a. 20 times 4 is going to be 80, so we get plus 80 is equal to 200. When we subtract 80 from both sides, we want to subtract 80 from both sides to remove the positive 80 over here on the left, and then we have to do it to both sides to keep the equation balanced. What we're going to be left with is 3 r sub a is equal to 200 minus 80 is 120, because of course we got positive 80 and negative 80 to cancel, so we were just left with 3 times r sub a on the left, and then 200 minus 80 is 120 on the right. Now, because we have r sub a multiplied by 3, we want to do the inverse operation and divide by 3, but of course we have to do that to both sides. We'll get 3 to cancel from the numerator and denominator on the left, leaving us with just r sub a, and then on the right hand side we get 120 divided by 3, which we know is 40. So we found that Andrew's rate is equal to 40. And again, even though we're dealing with subscripts here, this is no different than being given this equation here and being told that y is equal to 3, that w is equal to 20, and that z is equal to 4. If we had been given this information, we could have plugged in all 3 of these values and solved for x in the same way that we plugged in these 3 values and solved for r sub a. Using subscripts instead of just variables can be a more descriptive way to describe information, when instead of just unknown constants like this, you want to describe, Andrew's rate, Peter's rate, Andrew's time, Peter's time. So that's how you solve simple equations using subscripts.